solve the next differential equation. You should know that the differential equation of the form derivative of y plus some function of x, y is another function of x, it's given in the data booklet, can be solved by the method which is called by integrating factor. And notice that if there is some additional factor in front of the derivative of y, for example, if it would be x here, you need to divide each term by x to get just derivative of y, because we can solve if this equation is exactly of such form. And we can see that if we move negative 2y over x to the left, we get, I'll write just y primed instead of dy dx, it doesn't matter. So it becomes y primed plus 2 over xy is ln 2x over x squared. And we can see that a given equation is exactly of a given form. And the next step is to find the integrating factor. Formula is given in a data booklet, and it's e to the power of integral p of x dx. So integrating factor is e to the power of integral and this dx, because it's p of x, of course together with a sign in front. So it becomes 2 over x dx, and it is equal to e integral 1 over x, it's ln, so it becomes 2 ln x, constant is not needed here, and use the properties of logarithm, and for example a to the power of log ab, it's b, and if there is additional factor in front you should move it to the power of b, so it becomes finally b to the power of m. So it is equal to e to the power of ln x squared, and it's just x squared. And the next step is we multiply by integrating factor by x squared each term. So, and notice that you should write this. So it becomes x squared y primed plus x squared multiplied by 2 over x, y is x squared ln 2x over x squared. And the left hand side becomes derivative of integrating factor multiplied by y. It's always true, you will always get that the left hand side becomes derivative of integrating factor multiplied by y. And notice that you should write this. And it is equal to just ln 2x. Hence, if its derivative is equal to something, hence a given function is integral of the right hand side, or we can integrate both sides. Integral of derivative is just a function and is equal to the integral of the right hand side. So x squared y is integral ln 2x dx. How to find this integral? We can apply integration by parts. Y by parts, we know integration by substitution, but you can see that there is nothing to consider as u, or we know that we can apply partial fractions, but it's only for polynomial over polynomial. So, or actually from experience you should know that integral over ln can be found by integration by parts. And for integration by parts we should consider a given function as a product of functions, hence another function is 1, so we consider as ln multiplied by 1, and we should choose u and v primed. And if you choose v prime to be ln, you finally get integral of ln is integral of ln. So we consider u to be ln, and then derivative of u it's 1 over 2x multiplied by 2x derivative, which is 2. So finally it's just 1 over x. And v prime is 1, and v it's integral of 1, it's x. And then it's uv, it's x ln 2x minus integral of this product, so minus integral dx, which is equal to x ln 2x minus x and plus constant. We can find constant now, or solve for y and then find constant. So let's find y. Y is, we just divide each term by x squared, so it becomes x ln of x squared, so it's ln 2x over x minus x over x squared, it's 1 over x, plus constant over x squared. Notice that you cannot write here as another constant because it's constant divided by x squared. If constant divided by another constant, you may write as another constant, just c1. But here it must be c over x squared. And it is given a point, half 4, and we can substitute it to find c. So 4 is ln 2 times a half divided by a half minus 1 over half plus c half squared. We can see that there is ln of 1, it's 0, so it becomes 4 is 0 minus 2 plus 4c, and c is 3 over 2. Hence, y is ln 2x over x minus 1 over x plus 3 over 2x squared, and it's the required answer. Y as a function of x as required. And that's all for this question.